Good afternoon and welcome to Space for Survival. The session is being recorded and feel free to ask any questions during the sessions using the questions and answers box. In this session, curated by UKspace, the trade association for the space sector in the United Kingdom, there will be 4 separate presentations, each led by one of our member companies. And each one will look at space's role in the fight against climate change. We start with From World Monitoring to Climate Resilience, Predict, Prevent, Prepare and Precover, led by ICEYE.
Have a very large satellite to be able to carry. The main thing that we're trying to do is to fundamentally change the way that people look at the planet. Before ICEYE came along, the conventional way of looking at the planet was to use very large satellites, especially if you wanted to look in all weather conditions and day and night. You need to use synthetic aperture radar, which means that you have to have a very large satellite to be able to carry a big antenna. When ICEYE came along, we sort of looked at this in a completely different way. What we did was said, okay, global access is good, but we can actually do this with smaller satellites and make them more affordable. And then by having more satellites, we can actually see all the globe a lot more easily. A key requirement that's always been missing from the Earth observation discipline is being able to track changes very quickly and very timely. The cool thing about radar is that when we look at a point on the ground with radar, no matter what the weather condition is or what the time of day is, when we look at a point on the ground, it always looks the same to us unless something's changed on the ground. But there's an extra piece to this puzzle, and that is, because we transmitted our own photons, we can compare one image on one day or one time or one moment to one that we took from precisely the same location at a previous time. And then we can identify changes, not just changes that you can see with your eye, but changes in between those observations. If you're looking at a dam, for example, dams are usually used to host large volumes of water not far from where cities are. By monitoring dams on a moment-by-moment basis, we can see slight subsidence or ground eruption around the dam and maybe get a very early indication of when a dam's going to fail. And so the thing that's new about this is it's a level of persistent information, persistent imaging that the planet has never seen before. But the thing that really unlocks the future is by tracking changes and patterns over time, you get to predict slightly into the future. And that's the novel bit, seeing what's going to happen before it does happen by tracking the change of events.
Ladies and gentlemen, good morning. My name is Rafał Modrzewski. I'm the CEO of ICEYE, and it is my pleasure to be opening this next session entitled From World Monitoring to Climate Resilience. Prior to COP26, the Americans' envoy for climate, John Kerry, has stated that this conference is the world's last as well as best chance to fight climate change. In his interview for BBC, Mr. Kerry stated that if we were to prevent the temperature from rising above 1.5 degrees Celsius on average, we had to decrease the amount of carbon emissions by 45% by the year 2030. In addition to significantly cutting the emissions in near term, we must learn how to live and accept the consequences of the climate change that has already taken place. We must accept this new normal. This new normal, unfortunately, is more natural catastrophes. We will have to live and adapt to rising tides, more frequent forest fires, stronger winds that will happen more often, and flooding that's going to be almost ubiquitous. We must learn and develop solutions to protect our communities and people that live around the world. New concepts and new ideas must be sought out and implemented worldwide in order to help prevent those catastrophes and to respond to them. This is where Earth observation comes in. Earth observation technology, especially from space, has the ability to help us monitor our planet in order to understand the catastrophes that are about to come and to help us respond to them. Together with its partners, ICEYE has taken on a mission to allow governments and industry react to natural catastrophes. For those of you who are not familiar with our story, ICEYE has designed, built, and launched the world's largest constellation of synthetic aperture radar satellites. Those are imaging satellites that circle the globe and are able to take images of any place within hours from the moment we trigger them. They can see through clouds, they can see through darkness, they can access any place, anytime. This constellation provides a completely unique way of observing the world. The data that we collect can be converted into information which powers the decision-making in the most critical moment. Ever since 2018, we have targeted, imaged, and provided data for over 400 different floods and storms. We were there for Hurricane Dorian in 2019. We were there for Hurricane Ida in 2021. We were there this past summer when the huge European flood has taken place. And this list unfortunately goes on. What we see to be the case is as the climate keeps on getting warmer and warmer, the frequency of severe storms and floods is continuously increasing. The difference between the past and today is that today we have technology that allows us to monitor and react to these changes. At ICEYE, we often like to say, you can't improve what you cannot measure. Although the Earth observation technology won't solve the climate crisis by itself, it does bring us some hope. It allows to monitor the planet and to understand the environment we live in and the consequences that we are about to face caused by the climate change. We will need a collaboration of many disciplines to help and to achieve the goals set out by John Kerry and the attendees of this summit. As much as we'll need the government, we'll need the industry, and we'll need the consumers to really act together. However, this all must start with our ability to understand what's going on and measure the consequences. This is what Earth observation technology brings to the table. I hope you will join me in starting this transformation and enable the change that's so necessary to come. Thank you very much. I hope you enjoyed the panel.
Rafael, thank you very much for that, and some inspiring words and lots for us to pick up on there with an esteemed panel. I'm really pleased to be joined today by actually some very good friends that I've had the honor and privilege of working with for many years. Tuga, Matt, Shay, and Niraj from the Insuresilience Global Partnership, and Willis Towers-Watson from ICEYE and from Vivid Economics, respectively. Without further ado, let's just get into it. Matt, you and I have been in this space for a very long time, thinking about Earth observation data, GIS, and thinking about how we use that in the face of natural catastrophes, how we adapt, but also how we finance that risk. What are your reflections on what you've heard so far from Rafael and generally with the developments in this space?
Thanks, Daniel. Absolutely. As you know, my experience has been over a few decades now in the insurance and risk transfer space. And over that time, I think it's fair to say that there's been an element of frustration in the potential that Earth observation data could play in supporting more understanding around risk, better ability to put together effective risk transfer products for clients around the world in different areas. But unfortunately, that data has not been available in the formats or the level of frequency of coverage or the resolution to allow for those types of insurance transactions to be better supported. That's through a number of traditional and historical things. Obviously, the lack of the number of satellites that are available to capture the information at the timeliness that's absolutely necessary. It's really about time, ultimately, and being in the right place at the right time to capture imagery around events, for instance, but also then the availability of that data for the counterparts to be able to take a trusted view. You go all the way back to what insurance is about. It's about utmost good faith around counterparts. You need independent, validated data that can be assessed and applied in the most appropriate ways within those insurance transactions. Up until very recently, that data just hasn't been available in the format, as I said, or the temporal, spatial frequencies that you need. That's changed. And it's changed because of the availability now of the types of constellation satellite information that allows for that frequency. It allows for the resolution to be captured spatially as well in terms of being able to capture the actual impact on the ground of impacts, for instance, of shocks of flood or windstorm or other damaging events. But it equally, I think, gives that validity. It allows people to see an independent view of the actual events as they occur, how they then transpire into the damage and therefore into the loss. And so this is really changing the way that we can understand the events and then make more effective risk decisions and therefore better products for clients around the world in every aspect. The last thing I'd say, of course, is that products are changing. The need for different products, for things around parametric insurance, for instance, things that then provide new ways of dealing with evolving risk, particularly in the climate space. We need the data to plan and design those products more effectively. And again, the confidence around the data that's going to underpin those types of products is absolutely critical.
Matt, thanks. There's loads there that's really, really rich. I will, in due course, bring in Niraj Shea to get into some of the technical detail, really around the solutions. But I just want to take a step back with Hugo, if I may, in the first instance. So we heard a lot there from Matt around what kinds of solutions this data enables, but he also mentioned the need. And you sit at a very interesting place where I think you see that need very, very clearly. I wondered if you could put the solution in a wider context and explain that need in greater detail for us.
Absolutely, thank you. So at the Insuresilience Global Partnership, we work with over 100 members, including government, private sector, development partners, NGOs, and academia, with the common vision of scaling up access to disaster risk finance and insurance, which enables timely response after disasters. In order to manage risks, at the very start, we need to have a better understanding of that risk. And time again, we hear from countries that we work with that there is a gap in that understanding. There is not enough data or not the right kind of data, not the view of data is not complete. And one of the things that it would do is it would enable what Matt has spoken about, insurance transactions. But also at the heart of Insuresilience Global Partnership's vision is we're looking to promote a comprehensive risk management approach. We're not just looking to promote insurance transactions. We're trying to look at what portion of risk should be reduced, what portion of risk should be transferred, what is the adaptation policies, what are the infrastructure projects, what kind of resilience should be built into that. And that is how we can take a more comprehensive resilience building agenda. We can't do that without the right understanding of risk, and also to ensure that this is very much, it requires to be able to do this properly. We need to bring in different stakeholders who can contribute differently. So one of the things that we found is having certain engaging processes, bringing in risk modelers, bringing in the private sector, but also bringing in government stakeholders, bringing in farmers associations, and those that can then help us fact check, ground truth the risk models, and really come out with something that is useful and can guide policy.
Thanks for that. The clue's in the name, Insuresilience Global Partnership, right? It's a collaborative effort, and the problems that we're trying to address are so large, they're not going to be solved by the private or public sector alone. It needs collaboration. Maybe we'll come back to that in a minute. Niraj, you sit at an interesting crossroads, right? That's that crossroads between, as I see it, development economics and the geospatial technical angle. And I really like what Tuga said when she effectively, if I can paraphrase, explained that insurance is never going to be a panacea. It's not a silver bullet, right? It needs to be in consideration with adaptation and other development considerations. So given this kind of technology that we're talking about, where do you see the opportunities? Interested in your perspective, please.
Thank you so much, Daniel, and thank you so much, Matt and Tuga, as well, for those perspectives. Well, I basically concur quite a lot with Matt on kind of like the promise of remote sensing, because I've sat on the side of the remote sensing community for a couple of decades now, and trying to push products into different domains of economics as well as insurance. And kind of there's been that frustration as well on why there hasn't been kind of like the uptake. And there's been a few barriers to that, right? There's been like the data inconsistency, the data quality, and those sorts of things have now been kind of like with the rise of synthetic aperture radar satellites, which we basically just now saw, have basically given us a whole new stream of data, which is very continuous, very real time, and allows us to basically design a lot of innovative insurance products around it, which basically not just looks at insurance, but also looks at basically adaptation decisions as well. So for instance, Bangladesh, where there's a very large protection gap, recently Vivid Economics, we basically partnered with ICEYE to basically design a parametric index insurance product for relief costs, for emergency relief costs. So that the design of the product not only basically leverages such innovation, but there was also communication of risk, of how risk changes to the government and then on to the eventual beneficiaries, which allows them to appreciate more how basically they can appreciate and characterize the risk more. So I think that definitely feeds onto decisions around risk resilience, adaptation benefits, and all of that, which also comes with it. So I think the rise of these different satellite technologies definitely gives us more innovative products, which we can quickly push into areas where traditional indemnity insurance isn't basically there. And that allows us to basically bring more of an awareness around general adaptation measures as well.
Thanks, Niraj. And if there's time, and I don't know if there will be, we can get into parametric and some of the more technical insurance products. But the one thing I take away from what you said there, and I'm reminded of a phrase that we used inside UNDP, which is that development is not sustainable unless it's risk informed. And that means we need to understand the risk in the first place and put in solutions that are not risk aligned. Shay, our colleagues here have spoken a lot really about the need, but also you can see excitement around the table for the solution. And I hear things that Rafal and others talk about coherent ground track repeat and persistent monitoring. What are you seeing as the latest advancements, and how are you able to bring this to bear?
Yeah, absolutely. I mean, I think, what some of the other people on the panel here have talked about and have mentioned is, there's this obvious desire to assess and understand risk. I think Matt had a great point about kind of building a faith and a trust around quantifying information. And really that's fundamentally what platforms like ICEYE Star Satellite can provide, this quantifying, verifiable observation of actually what is happening. And fundamentally with persistent monitoring, we can really capture this precise time series of the physics that's going on in the earth, whether that be flood or wildfire. And from day to day to day, we can really measure down to millimeter level change. And so that gives us this really beautiful and comprehensive quantifiable evidence of what the observable Earth is undergoing and how that impacts people. And so, it's kind of moving beyond the faith aspect, but actually, building that up with the actual science and the data. And of course, as I think generally, or maybe collectively, we think of climate change, of course, as these long-term events that will continue to impact us, quite some time in the future. There really are, obviously to date, like these clusters of really dramatic short-term time series events that have been a challenge to observe persistently. And now we're able to do that and really capture, again, those dynamics. And so if we look at like the EU floods that happened earlier this year, with 15 centimeter rain in 24 hours and over 200 or so deaths, that was a really dramatic event, and we only see, a continued uptick in that kind of situation. There's, I think, a projection for 2100 of global displacement of 50 million people, related specifically to flood. So really the timing is right to leverage the technology that we have and really use it to quantify all these elements and improve some of the risk modeling and the ability to assess the impact.
Again, this conversation is so rich, we're going to run out of time to everything I want to talk about. I'm going to put a pin in this idea of prevention, but also prediction. And I want to see whether actually the technology is good enough to help us predict as well as prevent. But before I go there, I want to pick up on this idea of trust, of faith, of fidelity. You brought it up, Matt, to begin with. I mean, it's what the insurance industry stands for. It's a promise to pay, and that promise needs to be good. I'll direct this at you, Matt, but anybody feel free to come in. You, at the end of this, Shay, talked about risk modeling. And I know, Matt, that's an area that's very dear to your heart. And when we do risk modeling, we're often working with synthetic event sets, right? We're building hypotheticals, we're simulating. And here what we have, on the other hand, is truth data. If one is maybe the modeling is the religion, right? There's always a little bit of, you can have one model, but you can have 30 different opinions on that model and how good it is. And now we have something else which we can actually say, this is empirical evidence, this is how high the floods were at a given point in time. When you think about the way the insurance industry works with data as religion, and now we have this idea of data as trust, how do you see it being able to combine those two in a positive way? And can that inform not just how we respond with claims, but also how we design products and underwrite?
Absolutely. In terms of the models are there to inform as best as possible, but they're models. And a model will always be as good as the underlying information that's used to create it. As you and I both know, Daniel, from our backgrounds, models are not the panacea in the same way that insurance in terms of informing on risk. They're a directional tool set. They're there to provide guidance. They do not provide the answer. And one of the biggest challenges with natural catastrophe type models, the ones which are there to inform on the extremes that could occur, as you said, going into the future, is, of course, the future is unwritten. And we don't know exactly what's going to happen. There will always be things that the models have not properly captured and have not properly represented. The best thing you can do with models is to try and calibrate them as much as possible to the observed information that you see. And Shay's already said, these things are non-stationary. You can build a model, things will change. They're changing daily in terms of the potential that's happening. So the model is going to need that calibration. Having the ability to capture and utilize information that is continually monitoring events around the world, setting those things up with the modelled assumptions that are being put into the fundamentals of how those models are constructed, particularly around the physical aspects, but not only. That means that you're going to have more confidence ultimately in how that model is then being deployed and calibrated to the potential losses that could occur. It goes back to that confidence thing. Ultimately, you've got to have confidence in the tools you're using to make decisions. And the more you can calibrate them with good quality, independently observed data, the better. That empirical evidence base to these models.
Well, and then for me, and Niraj, you may have a perspective on this, but it's about how we bring this together, right? We don't want a modeling environment and then an empirical data environment. We need to be able to have the two, because there's value in the both, right? And they complement each other. Any thoughts on how we combine them?
So I think a couple of quick points. So I think one is on the persistent monitoring. So I think what persistent monitoring basically does is it gives you a very rich time series, very small snapshots, but a very rich time series. And it's been, I think, one of the gripes from the insurance industry that for a lot of the latest satellite technology, you don't have a long enough historical record to basically price products on. So I think the persistent monitoring in a very short span of years is going to give us a huge amount of data for events basically which dynamically change quite a lot. So it throws open a huge amount of predictive analytics for some kind of problems. Secondly, I think there's another, we are at the cusp of another like different wave of big data mining and machine learning. And I think remote sensing is an ally, and together with machine learning, and basically it can be combined with a huge volume of data that persistent monitoring is going to produce, basically give us and marry those empirics as well as the synthetic data sets and tell us an interesting story. So I think we can basically combine all of them into something really useful.
So I like this. Can I tell you what I'm worried about? I'm worried about the countries where Tuga operates. I'm worried about the developing communities. I'm worried about the capacity in those governments. Because what you just described, I understand, but even I know that's not easy. So Tuga, do you have a view on what it would take in order for the counterparties, whether they be governments or they be local insurers in the countries that we work with, in low and middle income countries, how we enable them to consume this capability?
Absolutely. And I have to say, I really agree with Matt and Niraj on this need to calibrate and to really bring in different stakeholders to ensure that the model is giving us the information that we want. Ultimately, these risk models are a set of assumptions. They're built on a set of assumptions, and it's about the interaction between a weather phenomenon and human behavior. And so there is a need to bring this all together. A good example of this is one of our members, but there are others doing this, but one of our members, the African Risk Capacity, they provide, it's a sovereign risk pool that provides drought insurance to their country members. And what they do is they mobilize a technical working group, which brings together different ministries, private sector representatives, insurance industry, local insurance industry, farmers associations, academia, and it wasn't always this way. As through their trial and error, they realized that actually it's not enough to bring the Ministry of Finance at the end of the process when the policy is ready, because actually the Ministry of Finance can actually tell you when they had certain spikes in their disaster risk management budget for a year. They could also, the Farmers Association can tell you when practices changed. And there was an incident actually some years ago where between 1 year and another, farmers had changed from a certain type of crop to another due to impacts of climate change, and they had felt that they had been impacted several years in a row, and so there was this push and change. That wouldn't have been known at the centre, that would not have been known at the capital. So it's very important to have different perspectives that feed into this model and validate the assumptions underlying them. And another really good example, if I should very quickly talk about, is actually who you work for, Daniel, at UNDP. Also a member of the Insuresilience Global Partnership. We have the tripartite agreement between the insurance industry through the IDF, UNDP, and the German government. And this is fantastic because it recognizes the strengths that each of these parties bring. The insurance industry is fantastic at modeling risk. UNDP is really good at engaging governments and really bringing in the stakeholders needed to shape the program, build the capacity on the ground, but also inform the model to ensure it is actually picking up what is happening on the ground.
Thanks, Tuga, and thanks for referencing the tripartite, and thanks for using that phrase on the ground, because UNDP exists to do those hard yards with offices in 170 countries where, frankly, getting stuff done is difficult. But we can't do that without the private sector's partnership. Che, can I bring it to you? Because I mentioned this notion of prediction. And that came out a little bit in some of the videos that were played with Profile. And the idea that we don't just use this data to underwrite or even to accelerate and expedite a response, but we can predict what's going to happen, that we can see before. And I'll go outside of the developing world for a minute. I think about the Surfside tragedy, which was essentially a subsidence issue, or I think about dam failures we've seen in the US. Is the technology at a place where we can really see millimeter changes in buildings ahead of time that would allow us to infer that something is about to happen and that we can actually get ahead of an issue? Are we that far along with the technology?
Yeah, I mean, surprisingly, or maybe not, we are actually, and in fact, you know, we're still very much so proving out, you know, what does this trade space look like? How tight of an accuracy can we really do here? But you know, I think what we've seen so far has been incredibly encouraging. So, you know, for instance, with ICEYE's coherent ground track repeat data, where we have this daily, persistent, highly precise, restricted view, like we're every single day looking at a location on Earth with exactly the identical viewing geometry. We've done things, for instance, looking at the Mosul Dam and seeing the structural challenges that are well known and published, you know, more generally, but you know, we can see that millimeter level deformation that definitely lead to you know, potential repercussions of the dam, you know, having a failure situation. So, you know, it is things like that I think with this capability, you know, we will continue to improve it and be able to start building these rich stacks of data, time series stacks of data for a variety of different locations. And we're really just starting to scratch the surface there. So it's incredibly exciting, going back to the ability to, you know, have that quantifiable, verifiable information, and then use that, those observations to really improve the predictive capabilities. So look and see and estimate, you know, really when will this dam fail, or when could a flood happen? I think, you know, going back to the natural catastrophe side and looking at the vast portfolio of floods we've been monitoring, for instance, we have really been able to start identifying trends in the different types of floods as a function of different regional locations. And there's a lot of subtle nuances there that will continue to further enhance our ability to improve response and start, you know, understanding how we could better serve new products and new clients and assist with just general global resilience.
Yeah, that's really exciting, and I'd love to follow up afterwards with you on our ability to predict and therefore to prevent. And at UNDP, one of our sister entities in the family is UNDRR, the United Nations Office of Disaster Risk Reduction, and their mandate is to get ahead of the disaster before it happens. And I think there'd be a lot of application there. Rafal mentioned Secretary Kerry. I was lucky enough to join him for a breakfast on Wednesday. He brought with him a message of hope, of course, a message, Tuga, of the size of the challenge, especially as we know that the climate risk issue gets distributed down, unfortunately, to those who are least able to bear it. But I think there's reason for hope. And one of the reasons for hope is the advancement that we have in the geospatial technology, whether that be spaceborne, airborne, or in fact in situ. And there's a lot when we get people around the table, technical experts, but also development experts bringing together the correct parties. And I think we have a reason to be hopeful. It remains only really for me to thank you all. Niraj, Vivid Economics, thank you for being with us. Shay, thanks for sharing your perspectives from ICEYE. Matt, always a pleasure to have Willis, Powers, Watson, join us, and Tuga, lovely to see you representing the Insuresilience Global Partnership. Thanks very much, everybody, for joining us. Hope you found the session valuable. Bye.
Our next session is how space can help support the COP framework and is led by NPL.
So welcome to this panel, where we aim to explore some of the ways that space and the UK can help support the implementation of the COP framework through delivering trustworthy, timely information, following on from the previous session. I am Nigel Fox of the National Physical Laboratory, where our role is to help ensure measurements and derived information have the right metrics to allow ready assessment of their fitness for purpose and are internationally consistent through traceability to the international system of units. In this EO and climate context, we are international thought leaders amongst the world's metrology institutes, supporting calibration of sensors, assessment of the uncertainty of observations, validation, and ultimately ascribing confidence to the derived information. I'm also the UK mission scientist for the Truth satellite mission, which will look to become the gold standard reference for optical space data in the next decade. I have the pleasure of moderating this discussion. And if there are questions from the audience, please do put them in the chat. We will try to bring them in if we can. And I will now ask the panel members to introduce themselves and their perspectives. So we can start with Peter.
Thank you, Nigel, and good afternoon, everyone. So yes, my name is Peter Anderson. I'm the Chief Commercial Officer of AAC Clyde Space. Just very briefly, I prepared a couple of slides, so I will just shift across to those. So yes, I mean, the title of the thing is how space can support, but from our point of view, we're interested in how AAC Clyde Space can support. So just very briefly on AAC Clyde Space, our vision is to deliver high quality, important, timely data, also incredibly important, from space for a better life on Earth. We were founded in 2000, I should say 2005 rather than 2015. So we're about 15 or 16 years old, and we're actually headquartered in Uppsala in Sweden. We're a world leader in small satellite technology and services. We're roughly about 170 people across 6 countries. We're a publicly traded company, and we have extensive heritage and a proven quality. And our main focus, and especially when it comes to the space data as a service, is on the blue economy and the environment. And obviously on the right-hand side here, what I wanted to show was an image taken from one of our spacecraft that looks at ocean color monitoring. And just very nicely, it is actually just where COP is being held. So I thought that was quite a cool wee photograph. So what can we do, and what can AAC Clyde Space do to help? The Global Climate Observing System has 54 sort of key essential climate variables, and 60% of those can be addressed by spacecraft. What a company like ours does is we actually facilitate a lot of other companies and ourselves with our own data services to access that data from space. Wildfires, looking at air pollution, maritime efficiency, water quality, I showed one just in the previous slide, of course, precision farming, improving access to healthcare, and also then just as a more general kind of interconnectivity for the globe. And really, and I'll pass over because obviously I want my fellow panelists to have a chance to introduce themselves, but I hope we get to talk a wee bit about some of these specifics during the next half an hour. So Nigel, thank you. I will work out how to stop sharing. I think that's it. Cool.
Thank you. And if we could pass over to Anthony.
Thank you. Yes. So Anthony Baker, CEO of Satellite View. So Satellite View is going to launch a new satellite that has an infrared camera on board. It's super high resolution, and it can revisit the planet multiple times a day. And this is a unique capability. So we could measure the heat emissions from any building on the planet and report back, throughout the day on this. And this is really, really important if we want to know where in the world we're wasting the energy. So which buildings are emanating the most energy. So the International Energy Authority says energy efficiency is the first fuel for achieving our climate challenges. The first fuel reduces the cost of other mitigation. So it's super important to be energy efficient. And buildings contribute 40% of our carbon footprint. And everybody who's declaring net zero, and we've heard a lot of that this week. Mark Carney has said he has a portfolio of $130 trillion under management, and everyone's declaring net zero. But everyone has the same problem. They don't know the carbon footprint today. They don't know where to spend their first money to make things better. And does it work over the long term? So we've seen the Bank of England committing to more green bonds. We've seen the FCA, the Financial Conduct Authority, prioritizing ESG. But when they have these investments, are they as green as they thought? If you're investing in improving a factory in China or buildings in London, are they better over the long term? And Satellite View, being the thermometer of the world, can help fix this.
Thank you, Anthony. And if we move to Jamie.
Well, hi, everyone. Thank you very much, Nigel, and good afternoon. Thanks for the opportunity to join this panel session. So just to introduce myself, I lead the data platforms, space data platforms and applications business at CGI. We're a global IT company, and we operate in 40 companies around the world. But we have a real specialism, particularly in Europe, for space solutions and space control. So we've built mission control solutions for many ESA satellite missions and commercial satellite missions. We build onboard software, and particularly we build ground segment solutions. So these are solutions which control the satellites, receive the data, process the data, and put it in the hands of the end users. And we work with our customers just globally on the space side and more generally to build solutions to their problems. And climate change is really becoming a big problem for our customers. For our global IT business, we every day we're having conversations with industries and verticals, from manufacturing, transport, to the insurance industry, for example. How can we help them to reduce the climate impact and the environmental impact of their own operations? How can they achieve net zero? And space data really has a role to play in that. So I spend a lot of my time working with those industries and those clients on how we can use space data to help them reduce their emissions, how they can get to net zero. CGI has its own target of net zero by 2026. So we're actually trying to turn that space data into real actions and how to really resolve some of these problems. We're also helping customers to deal with the consequences of climate change, so to design their operations to be more resilient, how they can use space data to anticipate problems and forecast problems and prevent them before they occur. So things like wildfires, floods, for example, how can we actually stop those things from happening in the first place? And if they do happen, how can we mitigate the consequences? We're very involved in the Truths mission. For example, we're leading the design and specification of the payload data ground segment. And that's really key for adding that layer of quality on all this data, which, as I said, is really now being used to make real business and socioeconomic decisions. So we need to make sure it's highly validated. And finally, I'll mention the fact that we're working to bring modeling and simulation into this environment through things called digital twins. And really it's about bringing the space data in contact with real models and accurate models and putting that into the hands of decision makers. And hopefully we'll talk about that more today.
Thank you, Jamie. And last but not least, Jeff.
Thank you, Nigel. Pleasure to be here today. So I'm Jeff Boswell, Head of Marketing and Sales at Telespazio UK. So Telespazio are a leading global satellite services and solution provider. We've done a lot of work on the system and services side relevant to climate change and data quality assurance over the last decade, including in ESA's climate change initiative, in the Copernicus Climate Change Service, in the current UK Truths mission that Jamie just mentioned. So we're looking at the flight operation segment side there. We've been doing work with the World Bank on climate resilience, with ESA on digital twins, and we've also been engaging more and more in recent times with the private sector regarding climate risk. And to try and bring an example to life a bit more, I wanted to touch a bit more on our digital twin work, and I think this is very relevant to one of the COP26 goals, which is the subject of this panel. So goal 2 is about adapting to protect communities and natural habitats, and that's very relevant to the digital twin work. And some of you may have heard about the digital twin initiative, but the background here is that there's a major European Union initiative called Destination Earth that is looking to create a high resolution digital reconstruction of our planet, a so-called digital twin Earth. And the idea is to have outputs that will provide better information for decision-making purposes for policymakers using both observation and predictive capability. And ESA are supporting the EU on this and went out to tender for so-called digital twin Earth precursor projects. And we're leading one of those, working with academic partners like the University of Leicester and the University of Reading. And those contributions from the academic partners are, of course, absolutely key in bringing through some of the cutting edge R&D concepts. And our project is focused on producing drought metrics in Africa, looking at variables like the wet season length, the start date of the wet season, and the number of dry days. And we've developed a climate explorer in the project that contains preset simulations using climate scenarios. But what's really exciting about this is the power of the machine learning approach that we've adopted with our academic partners. And this essentially allows the user to dynamically explore variations to these scenarios and ask their own questions, like, for example, what % reduction in precipitation would result in too many dry days for your crops to be productive? Or how do the wet seasons in different regions of Africa compare to each other under different climate change scenarios? Or how many additional dry days might you expect in a given region under a given climate change scenario by, say, 2060? So I'll stop there, but I think that's a good example of being able to turn the underlying data into easily consumable information and ultimately gain knowledge, which is, of course, really important in the decision-making process. Thank you.
Thanks, Jeff. Well, got a few little questions that we'll throw around the panel for some discussion, and I'll bring it back to Peter to start, really, and give you an opportunity to follow up on some of the things that you were talking about earlier. And you know, forests, saving the forest has been highlighted as a major achievement that's come out of this COP. So as to help counter the impact of greenhouse gases. How do you think space is going to help in this objective? And also, what other ways perhaps can space support mitigation and adaptation solutions that from your perspective?
From our perspective as AEC Clyde Space, for us it's what space provides in terms of global coverage, and earlier on I kind of made point to saying about high quality, timely data, and Anthony went on obviously to follow up on that with some of the work that Satellite View are doing, and I think it's really important to kind of note that, and I did want to bring up the global climate observation system, because it, you know, of those 54 key indicators, 60% can be monitored from space. But that's really important, not just the number, but the fact that it can be done from space means it can be done globally. It can be done in a manner that provides a really high level of understanding, and it can be done, and I think, you know, we'll maybe talk later on about the amount of data, but certainly it means then that commercial companies are getting more involved in the monitoring of global assets, and those assets being things like forests. And I recognized Adina on a previous call, and I believe she's in part of these sessions later on for GHGSat, who look at the, you know, emissions of methane and CO2, etc. So actually being able to monitor and actually kind of bring people to bear is quite an important aspect of what space can do. Specifically in forests, then it's about the monitoring, and you hear stats all the time about football fields a second being lost, and I think the ability to track that accurately, to report on that, to then also identify where we can help and sort of, you know, what resources we do have, which are extensive but ultimately limited, where they can be applied for the best. You know, I think personally, I think it's a one for all and all for one type of approach to keeping to our targets. There's no point in everybody doing it and then, well, not everybody doing it, and I think space can really help to monitor that. Oh, sorry, Nigel, I think you're on mute.
You missed that one. Anthony, perhaps just following up on the similar question and allowing you to expand a little bit on how your vision and your company is looking to try to deal with some of the mitigation solutions, and I know you explored that a little bit in the start, but perhaps you'd like to expand on that a little bit in terms of the thermal benefits.
I think the thermal layer is a new layer. So going back to forests, the space industry already does this with visual. They can see on a regular basis, you know, what's been cut down. Radar can help look at the canopy. I think there's new sensors coming on board, and infrared is going to be one of them. So obviously we can detect slash and burn and really localize it from an hour to an hour basis and at a very high resolution. which is new, and but also the associated industries around that. So the truck that's dragging away the tree trunks, has it moved recently? You can see it visually, but has it moved? We can see the engine block, and yeah, that's been moved in the last half hour. You can sort of get an indication of that activity. Or that sawmill down the road, it's not being used for months. Oh yes, it is, because we can see essentially what's happening inside, and there's a lot of energy coming out of there. So I think the satellite data, as Peter was suggesting, is really an independent set of data that gives the truth about what's going on in the world. And I think good that COP set lots of targets. Good that everybody's here agreeing to these, but I think where space can help is on that first step, where you should spend your money first, and the efforts, and then secondly, did you actually do it, and was it effective? And space is that independent eye and global, and so we can really help out in this situation with new data and new techniques.
Thank you, thank you, Anthony. Perhaps a slightly different question, Jamie, just to get you back into stream is, we've mentioned all of this data that we're going to get and all this information. Is government, commerce and public ready to exploit it? And do you think they're going to act on it?
I don't think they are ready to exploit it, if I'm honest, Nigel. I think about the volume of data that's being produced today. I think we heard ICEYE mention monitoring things to millimeter precision around the world. Just visualize how much data that is. We look at the Copernicus satellites, they're generating petabytes of data every year. And then there's all these commercial satellites generating all this data. Making sense of all that data and narrowing it down into actionable insights is incredibly hard. And having the data, having all this imagery out there is absolutely fantastic. We have to have that. But it really needs to be boiled down into something which is digestible and suits the questions that the decision makers are asking. So decision makers don't go in and just explore the data. They're going to ask specific questions, and they expect specific responses that answer those questions. So a good example is a project we're doing with ESA called the EO4SD Lab, where we're using space data. So Anthony mentioned that independent eye that space can provide. Well, the EO4SD Lab is the Sustainable Development Lab, and it allows people in the or project managers in the sustainable development community to use space data to monitor the sustainable development projects which they're funding. So the UN, the World Bank, they fund these projects for sustainable development, often with a climate change or a mitigation or resilience angle, or to reduce emissions. But that project is happening halfway around the world, and they're not able to go and visit the project. They're not able to actually verify that it's working, and that the work that's being funded is actually being done. Space can do that, and so we've provided that link between those project managers and those projects using the space data. But they're not actually interested. They're not interested in space data. That's not what they want. They want to use space as a tool. It's another screwdriver that they have in their toolbox, and I think that's where having the work that we're doing, Telespazio doing, other companies are doing to put that data into the hands of government and into the hands of businesses, and working with those customers so that it's part of their underlying data systems. It's not a new data system, it's part of the data systems they already have. That's where we'll really get the benefit, because then it will be brought into all of their decision-making process from day one, rather than being a bolt-on. And I think that's so important for climate monitoring, because climate's got climate change mitigation and emissions and net zero. It's got to move away from being a bolt-on and something we just do on top of business to being a core part of everyday business for all organisations, public and private.
Thanks, Jamie. And Jeff, just following up a little bit on this, on a similar question, really, but you explored or started to explore in your introduction about some of the activities you're doing with risk prediction, and we had in the previous session talk from the insurance sector. How are you finding commerce and industry responding to data? Are they demanding it? Are they demanding requirements, or is it a push type scenario that is there? How do you find that response?
Yes, thanks, Nigel. Yes, it's a good question, and I think there is some change afoot that will be driven by some of the mandatory requirements that are coming in on, for example, on the climate risk disclosure side. So I was at COP last week, and Finance Day was on the Wednesday, and the Chancellor announced last week at COP26 that it will be mandatory from April next year that our largest UK registered companies will need to disclose climate-related financial information on a mandatory basis. So this is quite important, because it's going to drive the demand for information on physical climate risks that are relevant to a company's asset portfolio around the world. So, for example, this can include the likelihood of extreme climate events in a given location, such as droughts, floods, extreme rainfall, wildfires, high winds, but also noting that the risk now in a given location for an extreme event could be quite different to what it was 20, 30 or 40 years ago because of climate change. And I think the challenge here is that you've got sort of risk and asset modeling organizations, and then you've got organizations that can supply good information, observational information and modeling information on physical climate risk. And it's trying to combine that information together for these different industries to work together so that we can combine the physical climate risk information with localized information, for example, on the vulnerability of assets, to help derive overall risk exposure. So I think that's going to be the whole climate risk area going forward is going to be quite an important one over the next few years. So that's just one example.
Thanks, Jeff. I'll come to Anthony now to start this, just to change the order a little bit. But it's you're a commercial company. Is there an optimal public-private partnership, where we want to get good economic growth, delivering trustworthy, timely information, balancing the investment cost, the risk, the public good, and in that context, is there something that you would like UK government to do to help support the industry, and particularly, with the recent space strategy? Are there things that need to happen to help build that framework to happen?
I think it's touched on before. So we need that data out there. So I think the ideal for us is if the government was an anchor tenant for some of these satellite companies, including ours. And in our case, we'd like them to buy a thermal map of all the big cities and make that available to the councils, etc., and the mayors, because with that data set, it addresses so many problems. Immediately in the thermal, you see which buildings are the worst insulated, so that can direct construction companies, it can stretch, retrofitting, it can give information to insurance companies. And you can see whether the latest thing we've learned is that, when you pay for an upgrade, maybe it wasn't quite as good a job as you expected, and that afterwards the performance is good. So you've invested some green finance in there, and it's a bit of greenwashing going on. So these sort of things can be revealed from satellite data, keeping people honest and on the mark. So we need to measure, and I think the PPP relationship would really work.
Thanks, Anthony. Peter, you are in many ways as a company help providing the interface and delivering some of these solutions with multiple different companies and organizations. Are you finding the relationship and the funding models all working and coming together, or are there things that you would like to see happen?
I think where we've come from as a company, we've come from upstream. I think the funding models have worked very well for us, but I think moving forward, and just to echo what Anthony's saying, it requires a slight change in approach from some of the funding bodies and the governments to go from sort of the self-delivery model via companies like ours, sure, and actually buying the data sets sort of further down and providing even the commitment ahead of the data sets being available to help some companies actually get up off the ground and secure other investment. I don't think until very recently it's been a very easy play to get funding for a lot of environmentally focused applications. I think that's been quite difficult, and a lot of companies had to focus on some more of the commercial side of it to kind of get these things off the ground. So I think that's certainly, and I think really it's just at the risk of actually just saying exactly what Anthony said, I think the anchor customer, tenant customer is such an important aspect, and then it allows companies to then sort of go around the globe and resell that service on to other companies and governments and institutions as well. So I think it's vital.
Thank you. And Jeff, do you have any perspectives from from rather from the upstream to the downstream element in terms of infrastructure or services that government should be helping to provide and support?
Well, I think we've seen the space strategy come out. We hope that's a prelude to a national space program where we can really try and concentrate on having space information, data, and services as to truly underpin many other sectors in the private sector and in the public sector. So I think to give an example of how government could help, I think maybe on the underlying data infrastructures, there's an opportunity for government and the private sector to work together there to make some of these data sets, and also make them available with the right quality assurance information, so we can have that trust and traceability in the information that's provided, which is important for the decision making. So I think that's an area. I think the different government departments, I'm talking from the UK perspective here, I think they could probably work together a bit better to join up the requirement, because I think that there's a problem with cash flow and from government, and that might allow requirements to be pulled a bit more, to have a bit more efficiency in the process, to allow government to be an anchor tenant sometimes.
Thanks, Jeff. And just because I've got virtually zero time, Jamie, just give you a last chance to just have a last comment on that topic, or indeed any other topic, since you've got
I think I'd echo some of those points, but I mean, really, I'd like to see government walking the talk a little bit. It already uses space data. We've provided an Earth observation data platform service for DEFRA, for example. It's providing analysis-ready data for the whole DEFRA family. So government is already using space data. It could use more, and if it uses more, it will get the benefit. So I think it needs to start looking at how it can use space data itself more, and maybe some of that will result in some of these PPPs or so on. But the first step is really use the power of space data to improve government from day one.
Thank you, and thank you to all the panelists, since I know that we've run out of time. But thank you, and it would have been good to keep going further. But thank you, and thank you to the audience. And sorry we didn't get to answer your questions. Thank you.
Thank you very much, Nigel, and thank you everyone for that very enlightening session. Our next session, our third session, is space sustainability, safeguarding our orbital environment now and for future generations, and is led by Astroscale.
Thank you very much, Penelope. Hello, everyone. It's a real pleasure to be here today speaking at this event. My name is Harriet Brettel. I'm the head of business analysis at Astroscale, and I'm thrilled to be moderating this discussion today on space sustainability, safeguarding our orbital environment for now and future generations. So throughout this event, we hear about the importance of space-based data and services to support Earth-based environmental sustainability efforts. And as our reliance on satellite services grows and the space environment itself becomes more congested, it's important for us to think about the sustainability of the orbital environment itself. We very much recognize that providing these valuable satellite services is contingent on the long-term utilization and sustainability of the space environment. And I'm joined today by three fantastic panelists who are going to facilitate this discussion around this very important topic. I'll do a very quick introduction and then we'll dive right into things. But today with me, we have Joanne Wheeler, MBE, who is Director at Alden Legal, Jacob Gear, who is the Head of Space Surveillance and Tracking at the UK Space Agency, and Maurizio Vanotti, who is the Vice President of Space Infrastructure Development and Partnerships at OneWeb. We have very little time today to really dive into the detail of this topic, so we won't be taking audience Q&A, but please do connect with me via the Virtual Pavilion platform. I'd be very happy to discuss any of these topics further there. So let's get to it and dive right in. Firstly, I want to ask each of the panelists from your perspective, and we've got fantastic representation here from the regulatory and policy side, the industry side, and also from the agency side. How do satellite services rely on the safety and sustainability of the orbital environment? And how can or do in-orbit risks impact the satellite services that we rely on in everyday life?
Perhaps I could go first, Harriet, and take it from a national level. So we depend on satellite services for our everyday life. So for banking, for communications, for the sat nav in your phone, and when you're in your car, we need satellites. This week and last week at the COP event, we've been hearing about how satellites are crucial for monitoring logging or for monitoring climate change emissions. So we're absolutely dependent upon it across all aspects of our life. And really the growth in the number of satellites now reaching orbit. So I think in the last 2 years, we've probably launched more than the 40 years from 1960 onwards to really get new satellites into orbit. The change in the industry to have more and more commercial players entering orbit now, coupled with the amount of debris that's already up there. People don't tend to know about space debris. It's a bit like plastic in the oceans. It's there, it's floating around. But in space, if it hits you, it doesn't bump into you gently. It hits you really quite fast and it can destroy your satellite. That means that the satellites we depend on are in greater and greater risk. And as the congestion increases in orbit, particularly in low Earth orbit, so below around 2,000 kilometers, where we consider to be quite close to the Earth, really that's getting quite a busy bit of space now. And the more companies we see reaching space, potentially putting up new broadband connectivity, which is really important to connecting perhaps those bits of the world that can't have terrestrial broadband. Actually, that just makes the problem worse and the congestion more and more busy all the time. So we are facing an increased risk at a national level for everyone's way of life.
Thanks for that, Jake. I'll maybe pass over to Joanne if you want to add any more thoughts.
I completely agree with Jacob. I remember 8 years ago, SES did a project called No Satellite Sunday, showing how much we all on Earth use satellites. And I remember the statistic that hit me and has stayed with me ever since is when your alarm clock goes off in the morning, when you arrive at work, you've connected with 22 to 26 satellites. That was 8 years ago. Imagine the change now, but the sustainability now and long term of this orbital environment is vital. And as Jacob and Maurizio would know better than I do, the orbit design, orbital control is becoming a much more complicated task with fast growing orbital populations. Tolerances are small. Operators need an extremely precise, robust control and very accurate tracking. And what I would ask is, what is an acceptable risk here? Because the orbital populations are changing so fast. And even if we assess what an acceptable risk is, there's always opportunity for error or failure, as we saw with Iridium and Cosmos in 2009. And then, of course, there's lethal and non-trackable debris. So in LEO, as Jacob mentioned, the larger combined surface area, or shall we say collision area of satellites, and the growing nature of this makes this a real issue, particularly if large constellations are not managed properly. Not everyone is like OneWeb or SpaceX. And what happens is a large constellation with no propulsion. And to give a very quick example, there was a recent filing made for over 320,000 satellites in LEO, which begs the question, do we really need that many? Could design or other methods help reduce that dependence? Because we need to protect satellite services for vital functions on Earth. Thank you, Harriet.
Thanks, Joanne.
Thank you, Joanne. Thank you, Jay. Harriet, sorry if I jump in. I mean, fully agree with my colleagues. Think of a day without position navigation and timing services, without GPS or Galileo, whether it's for business reasons. So if you're sitting on a plane that is landing automatically using GNSS signals, or if you're trying to navigate towards your favorite restaurant, that we rely more than we think today on satellite services. Our 5G towers, are synchronized using GNSS signals, and this is just talking about position navigation and timing. Then we're talking about bridging the digital divide. It's really an Earth observation, right? So it's really on in our day by day lives. And actually, what I do like a lot is the parallel with which brings it closer to the men and women on the street, is with the traffic, with number of cars, right? It's called space traffic management for a very good reason, with the only difference that satellites cannot brake or accelerate as easily as cars when a traffic light turns red. But what is really important, as Joanne was referring to, is coordination. Actually, the ability to be able to maneuver. So the need to have propulsion systems on board.
Yeah, absolutely. And I think, Maurizio, you've kind of started to touch on our next question, which is thinking about, what are the regulatory or licensing developments that might be needed to support the sustainable use of space, whether that's for climate change observation or for other satellite services to remain effective. And I'll maybe start with Joanne to answer this question, and we'll go around the group again.
Thank you, Harriet. Really important question, actually. I was listening to COP26 on Monday, which was Loss and Damage Day, and they picked up three main themes from Monday: human rights, particularly the rights of future generations, crimes against nature or the environment more generally, and non-compliance with national laws. I just want to pick up a few of these themes. Space is an extension of the Earth environment. From a legal side of things, that's very clear cut. The rights of future generations on Earth should be the same as future generations, future companies, future activities in space, but we need to recognize this more fully. And activities in space need to be conducted in accordance with international law, including international environmental law. And it's worth touching on a few aspects of this. There is a principle hot-wired into international law, which is states must not permit the use of their territory or the use of their property to detriment other states. So think about that in low Earth orbit. You can't use your satellite or your constellation to actually adversely affect another state. And that would work in regard to interference, property damage, etc. But that's fine if it's state to state, but what about damage caused to environmental areas, the actual outer space as a whole, which isn't owned by any state? There are no binding rules in this regard. Isn't that almost shocking after COP26? So what I've used at European Space Agency and what I use in private practice is a non-binding principle, Stockholm Principle 21, that states have the responsibility to ensure that activities in their control that they're responsible for don't cause damage to the environment, whether it's Earth or in space, and space is expressly mentioned. So you cannot cause damage to outer space generally, but like space debris guidelines, this is non-binding. There's no international crime for polluting outer space. So how do we fix this? So there's a general duty to preserve and conserve the environment outside national jurisdiction, so the commons, but it's developing slowly. There's a precautionary principle, better to be safe than sorry, but it's developing slowly. There's a concept of this global commons and the global commons in outer space, but it's challenging. And the International Court of Justice on Earth came up with this wonderful concept recently, the duty to protect generations unborn. which reflects back to COP26 and the reference to future generations, and that includes the space environment. But it's all not fast enough. So to answer your question fully, the last point of COP26, and my last point here, is compliance with national laws. And I'm going to get philosophical just for 1 second. There was a philosopher called Edmund Burke, and he's been quoted by press and all over COP26 because he talked about an equality of restraint. And I think that's a wonderful term for constellation operators. And a social contract between the living and those yet to be born, active commercial companies and those yet to be in orbit, etc. And one journalist just yesterday said that this concept, equality of restraint and social contract, was a remarkable, powerful force to deal with the shirking of generational challenges like climate change. But so I've been talking about aspirations and the ambitions, and that all sounds great, but we have to enforce this. This has to be done nationally through laws and licensing criteria. I'm so proud of the UK supporting the long-term sustainability guidelines, but not every state is like the UK. And those guidelines are almost valueless unless they're implemented. So we need to enforce space debris guidelines and these environmental principles in national laws through licenses. And we need to do this to avoid unfair competition, which was a big issue when I was at the European Space Agency, and to avoid forum shopping. And states have a duty to authorize and continually supervise their activities. So how do we do this to avoid forum shopping and avoid competition? I would argue that the licenses that recognize sustainability need to be linked to raising finance. I'm afraid money still talks. And concepts like environmental and social governance, ESG, or McKinsey are hosting a big event in Glasgow at COP26 just now. Their phrase, sustainable, inclusive, and growing. So we need licenses that recognize sustainability. Those licenses are linked to finance. And we therefore apply that equality of restraint and that social contract through licensing. And that's one robust solution that I think the UK is looking at and other states should. Thank you, Harriet. Good question.
Thanks, Joanne. That was a very comprehensive answer, and I think you touched on a number of things that we could explore in a lot more detail. Maurizio, I want to hand over to you from the operator perspective, how you see those roles of licensing, regulation, and how that can support the sustainable use of space.
Well, thank you, Harriet. We have been and will also be in the future very, very vocal on this regard. And I would like to add another dimension to what Joanne was saying. There was the licenses aspect, there's the financial aspect, which also would translate into market access. So responsible space has really to be linked to market access. Is one of the ways. I'm not saying that the only way, but if you are blocking commercial businesses, to actually to operate in some particular markets unless they are not operating responsibly, well, this is the best way to find methods, to impose these guidelines. And until we're calling them guidelines, I think that people will not look at these with the right level of respect and importance, I would say. So market access for us is key.
Yeah, that's a great point. Thanks, Maurizio. And Jake, from wearing your UK Space Agency hat, would love to hear your perspectives on this question.
Well, firstly, I'm glad Maurizio went first, because I wouldn't try and follow Joanne with a discussion on regulation, because that was a fantastic answer, and I learn everything every time I listen to you, Joanne. From my perspective, just thinking about the international level here, so the UK could choose to regulate and say all of our operators, so people that are licensed in the UK, must abide by some really stringent rules. They must deorbit very quickly and have propulsion on their spacecraft to avoid collisions, lots of things. But as Joanne says, if we do that ourselves alone, then people just go elsewhere. We'll just make our industry less competitive compared to other nations. So the real key to this is the international collaboration at either a regulation level or even at the UN level, at the Committee on the Peaceful Uses of Outer Space, to really try and enact some binding rules across different nations. I think there are a group of nations that are trying their best to move out here, but that international action does take time. Until then, our new Space Industry Act, which is we're now licensed by the Civil Aviation Authority, I think is a really strong, world-leading piece of legislation. But perhaps we can't go as far as we'd like until we get other nations on the same page as us. And that international piece is really the focus of a lot of my work, and within government, the Foreign Office and other people like that as well.
Mm-hmm. Yeah, thanks for that, Jake. I think that's a really important point. And again, great segue into my next question, which is really thinking about, you know, this challenge around space sustainability and protecting the orbital environment. It's not something that any one individual actor can solve and address in their own, right? So this is going to require a really collaborative effort internationally, but also bringing both the space industry together, but also more broadly. So the next question I want to ask the panel here is, how can the space community advocate for the orbital environment to be considered as part of a holistic view of environmental sustainability? So really bringing space into that broader conversation. Happy for anyone to jump off here.
I can start, Harriet. I think it really, you know, goes back to the vision that each company really has. You know, OneWeb's, you know, since, you know, our inception, you know, our vision has been, you know, leave no trace in space. And we've launched, you know, our Responsible Space Campaign initiative. There are nowadays so many forums, working groups at national and international level that create a perfect opportunity for responsible companies that are willing to engage, to sit around the table, trying to work these problems out. Because I think the first step is, you know, recognizing that you know, we are going to end up having a big problem if we don't act responsibly in the very short term. The second step really is engaging with the community and walk the walk and talk the talk. We are doing this in many different working groups. You know, the Dark and Quiet Skies that tries to bring, you know, together astronomers, you know, that work in the different frequency bands. They're also talking with industry, with operators, with manufacturers. Something that we did with some of our fellow Constellation colleagues is to bring in, to convince these working groups to bring in the manufacturers, right? So, because it's not just about the operators, it's not just about the astronomers, is also about engaging with the manufacturing community that you know, is fundamental piece of this ecosystem and this ecosystem. Yeah.
Yeah, absolutely. I think that's a great point about thinking about this holistically, right? So this isn't just thinking about the end of life operations. This is how you can integrate this, you know, concept of sustainability into the design stage, the manufacturing stage, and the operational phase, right? So this is much more holistically considered. And yeah, Joanne, over to you.
I completely agree, Harriet, and with Maurizio, and even to the point of view of fuel, sustainable fuel. It's that whole arc from beginning to end of life. But in regard to advocating for the orbital environment, I think, just to echo something Jake said previously, I think we've still got a bit of a culture of out of sight, out of mind, or it's not quite happening in my backyard. And we saw this a little bit with the protection of the oceans, as Jake also said. Now, so I got a few years ago fantastic advice from the Space Agency, Jake. And they said that if you want to change something, you've got to make it relevant to the man who watches X Factor. That sounds really silly, but actually it's incredibly important. We need to influence popular culture. If you influence popular culture, you influence politicians, you influence ministers, you then influence the international community. And I think space community are doing a fantastic job. This event today, Harriet, is a fantastic example. But all of us need to make her message more accessible, more simple, and illustrates the man in the street or the man who watches X Factor why space is so important to everyday life. And an example that came up at COP26 on Monday about reducing emissions and renewed pledges, there's been a bit of a patting on the backs of various people, but the numbers haven't always added up. So the Washington Post looked at the gap of 8.5 to 13.3 billion tons between actual emissions and those reported. And you know how they identified the actual emissions? Satellite data. They relied on satellite data for accurate monitoring. And there are a number of climate cases, legal suits that are going on Earth at the moment. The last figure I looked yesterday, over 1,800 climate disputes. So I think that outcome might help shape it. But I think we all have a duty in the space community to really get our message over accessibly and simply, and influence that person who watches X Factor about what Maurizio just said, the value of space to them in everyday life, and the value if it's gone.
Yeah, thank you. That's a really good point. I mean, if we could fly David Attenborough into orbit and have him in front of a field of space debris, right, and talk about that, that would be fantastic for our job. I mean, he'd probably love to go, I dare say. But actually, it's hard to bring that visceral picture of space debris and the risk in orbit to mind. And we are thinking about the public perception of space debris and why space is so important and why we have to protect it. And we've got some plans in the next year to perhaps try and get something out a bit more sort of outside of the community, maybe looking at some of the arts sector. Perhaps actually there's something more we can do there to reach different audiences to talk about space and how important space sustainability is to all of us in the future.
That's fantastic, thank you. And I think this really goes to show that there's a role that each and every one of us can play, both in terms of from inside the space industry, but also kind of bridging that gap and communicating outside as well, and developing that messaging. All right, we're coming towards the end of our panel, but I've got one quick fire question for each of our panelists here today. So we've been talking a bit more collectively about what can the space community do to support and protect the orbital environment. But I also recognize that we've got a representative from a satellite operator, a representative from the space agency, and a legal expert here as well. And so I want to ask each of you just to very briefly answer, what steps are you taking specifically to ensure the responsible use of space for future generations? Feel free to take that in whichever order you'd like.
Shall I go first? You mentioned operators first, Harriet. So OneWeb has 6 work streams, is active in 6 fields as part of our responsible space initiative. So starting from space situation awareness, so we do share the position of our satellites, our ephemeris. They're available on our website, and we do share it with other websites, commercial and institutional entities. Second is space traffic management. We do actively coordinate with our fellow operators, like Starlink. We have a constant line of communication open that has been working brilliantly, it's fair to say. We are developing in collaboration with some companies, like Astroscale for the ESA Sunrise program, assisted disposal and removal technologies. Should we lose control of one of our satellites that are designed for active control re-entry maneuvers. We are actively engaged with radio astronomers and with optical astronomers. With radio astronomers, we do keep separation, the bands that we use and we're licensed for, in order to create an additional barrier, if you want, in order to protect the frequencies they are operating at. And regarding brightness, we're actively conducting observation campaigns to measure the brightness of our satellites, the footprint of our satellite in space, and use this information to correlate geometrical models and inject lessons learned into design of our next constellation that we launch starting from 2025. And last but not least is carbon footprint assessment. We have been assessing the carbon footprint impact of our supply chain, and we'll also, we actually have introduced guidelines as part of the request information process for our next constellation that we have launched less than one month ago.
Shall I jump in next? I'm afraid I can't apologize for this, Jake, but still pushing the Space Agency on a close proximity mission policy. It's really important. I don't need to tell you, Harriet, that it'll be great for Astroscale. And it's one of the top 3 priorities for a regulatory advisory group. And I was actually speaking to Space Agency this morning about it. We need a policy. We also need an EO data policy to make sure that we can distribute the data that the satellites, our UK satellites, can so brilliantly capture for monitoring climate change, etc., and make sure it's exported. There was a data policy 5 years ago that I was involved in drafting, but we really need to get that published now. So I'm really pushing those 2 things. I have been attending the British Standards Institute and International Standards Organization space debris meetings since, goodness, 1998. And it's a great group of people, but the issue is it's a great group of people and they haven't changed very much. There's no new blood coming in. Now that the landscape and the industry has changed hugely in 23 years, and we need to get more blood into the standard setting for space debris. We need to get more SMEs and diverse operators. OneWeb are represented there, thank you. But it's not a good sign if the space industry don't engage in standard settings. And lastly, I'm absolutely passionate about this ESG concept and sustainability, inclusion and growth. So I'm probably spending way too much time, but it's important writing papers and researching on this as to how it can be applied more conclusively to manage space debris and link this into finance. I think it's a brilliant issue and be really great for UK. We've got this brilliant set of companies here to build, launch, operate, in-orbit servicing, active debris removal, link that to insurance and finance. We've got something really special. Thank you, Harriet.
Thank you, Joanne. And Jake, I'm going to give you 30 seconds, if that's all right, to add
I knew I wouldn't get long, so I went last. Yeah, so I think the UK takes this seriously at a national level. So our national space strategy highlights space sustainability as a real priority. We're the largest contributor to the European Space Agency's Space Safety Programme. Just a couple of weeks ago, we announced a new national mission to go up and remove 2 old UK satellites from orbit. We're working with the United Nations Office for Outer Space Affairs to really implement those guidelines. And so across the domain, internationally, national, regulatory, we're doing our best here. The issue is to try and maintain that pace and to try and take other nations with us where we can. Thank you, Harriet.
That's perfect. And I think that's a perfect way to wrap up this discussion. I want to say a sincere thank you to our panelists for bringing a really diverse range of perspectives to this conversation. I hope this is very much the beginning of this kind of dialogue. There's clearly a lot more to discuss on this, but thank you everyone for listening in, and please do connect via the virtual platform. We'd be very happy to chat further. Thanks very much.
Thank you. Thank you.
Thank you, Harriet, and thank you, everybody else. Some huge issues touched on there, philosophical, technical and ethical, lots to discuss. Our final session is led by BryceTech and asks, what is space's role in addressing the issues of climate change?
Good morning. Good afternoon. I'm Carissa Christensen, and I am the CEO of BryceTech. And I'm pleased to moderate our next panel, where we're going to talk about what satellites do with regard to monitoring and measuring climate, and talk about an institutional construct that may help us use satellite data more effectively. I'm very pleased to introduce our panelists this morning, Dr. Simonetta DiPippo, who is the director of the United Nations Office of Outer Space Affairs, Adina Gillespie, who is the director of Business Development Europe for GHGSat, and Simon Tucker, who is the vice president of business development at Satellite View. Satellites are critical in understanding climate change. They provide some of our most important measures and insights into the dynamics of climate change, measuring air and sea surface temperatures, measuring sea levels, and as we'll hear today, measuring a number of other important indicators. And more effectively leveraging satellite data can help us move toward a net zero future through more effective mitigation. So I'll jump right in and begin with our discussion. And I would like to start with talking about how satellite technology has helped inform us about the current picture of Earth's climate and environment and how that fits into global trends. And I'll ask Simonetta to begin our discussion talking about that, and in particular, elaborating on a recent white paper called Space for Net Zero that emerged from the World Economic Forum Global Future Council on Space. Simonetta led the group that produced that paper. I'll also highlight the contributions of Dr. Alex McDonald from NASA, who was an active leader in putting that together. I was honored to play a very small part in that. Simonetta, I'll turn the floor over to you.
Thank you very much, Clarissa. It's really an honor for me to be here together with you and the other panelists to discuss this very important topic. And indeed, we have been hearing now several times, also today, that satellite technologies allow us to really understand better our changing environment and try to react accordingly. And indeed, as you were mentioning, the recent published Space for Net Zero report, which is a product of the World Economic Forum, is really emphasizing the critical role of space technologies and is also calling for global collaboration. Well, according to the World Economic Forum Global Future Council on Space that we both have the pleasure to, enjoy, let's say, together the possibility to discuss with other top-level experts in the world such topics. Well, according to us, to the Council, we need to consolidate really our efforts of researching and measuring Earth system variables. The report in reality strongly recommends the establishment of an Earth Operations Center that leverages space data and expertise to conduct global sustainable science. Well, I would really like to underline the word global science and global sustainable science and global sustainability science. Sound like a set of words, and also you may understand a different meaning depending on how you combine the various words, but these are all keywords and what we've been discussing quite extensively in this regard. Well, through the consolidation of global climate science, we can get the best possible understanding of climate change, which can then be translated into physical visualization and Earth information to support international decision making, which is exactly the goal of that. Well, for such a collaboration to be possible and to succeed, integrated data and interoperability of systems, as well as a multilateral collaborative environment, in my opinion and in our opinion, are really paramount. Promoting interoperability and strengthening international cooperation in the use of space science and technology, well, I believe is indeed at the core of the work that we have been doing, but for sure is part of my core mandate at the Office for Outer Space Affairs at the United Nations. And so it's quite a good synergy what we have been doing with my mandate at the office at the United Nations and the WEF, Global Future Council on Space. And I do believe that this is what we have been producing is quite a milestone in not a short process. I see that we have a long way to go, but I believe it's a very important first step.
Simonetta, thank you very much. Simonetta has laid out a vision for using satellite data in a global, interoperable, interactive way. Let's talk a little bit about what that satellite data is and how it can help us in specific terms. We're quite fortunate to have two innovative companies represented on the panel today, companies that are directly tackling the challenge of net zero. So we'll hear a bit more about their capabilities, the insights that they draw, and how those insights are being used in the world to move us in a positive direction. And let's start with Adina Gillespie from GHG Satellite. Putting this in context of this, this conference, we've seen targets to reduce methane emissions, for example. We've had 105 countries sign the Global Methane Pledge. Adina, can you help us understand what GHGSat is doing generally to move us in the direction of monitoring emissions and how that fits into what the conference is trying to achieve?
Yeah, thanks, Carissa. Thanks for the invitation to join the panel today. So I'm going to start actually by echoing what Al Gore said in the plenary session that preceded this one. No one company, no one organization, and no one person can do this on their own. And so we all need to be very careful about how we present ourselves in this context. It happens that a good part of last week was focused on methane emissions. And of course, for us in GHGSat, that's our core business. So we've been operating methane monitoring satellites since 2016, and we've been working with operators to identify emissions, to identify the leaks. That's the language we tend to use when we talk about emissions. We tend to call them leaks, and to resolve those. So we've now got 3 satellites in orbit, and we've got another 3 launching next year, and we'll be at a full complement of 10 in 2023. So that's all really good. There's lots more coming as well, and we all need to be a part of the solution here. So this is good news around the board that we're there to address it. For us in GHGSat, we just happen to be there at the moment in time with the technology in orbit that's delivering on this today. So to give you a bit of a sense of things, it's moving fast. It's moving really, really fast. So a few weeks ago, we went public with the first ever high resolution methane emission that was measured from a trona mine, trona being what we tend to know as baking soda. Last week, we put out the first ever high resolution image that captures methane emissions from an open cast coal pit. And just a few hours ago, we put out the first high resolution images or emissions measurements from space of landfills in Europe. We've been collecting landfills around the world for quite some time, and as time goes on, we just get more and more of these. And it's great to be there as the first, but what really matters, as you say, is what we're doing about it and the impact that we're having. So if we take those, if we take the landfills as an example that I just referenced, let's talk about things in terms that people understand. So I can talk about kilograms of methane emitted per hour, and that's all really interesting from the scientific perspective. But you know, the 2 landfills that we measured in August, they were emitting methane at a rate that would be equivalent to powering 350,000 homes. So these are really big emission sources that we can address. Some of the participants here today might have heard us talk about a success story that we had in Central Asia, where we monitored a very large methane leak that we found quite by accident in working with the scientific community. And that leak was the equivalent of 1 million passenger vehicles on the road for a year. So this is just one leak. So GHGSat as a company, we're out there right now actually working with operators, working with governments to address the problem, and we welcome more people coming to the party to help with this. And coming back to Simonetta's comments a minute ago, we can't stress enough the importance of the scientific community in this, and the scientific initiative that she's talking about is warmly welcomed by us as a business, because the science that's been going on as part of these decadal programs is underpinning a lot of what we do in GHGSat. So we want to make sure that we're not ever presenting, you know, one thing is the solution and the commercial organizations like ourselves can come in and solve all the problems. We all need to be part of the solution here. So thanks a lot for your time, Carissa, and I'll pass.
Adina, thank you so much. And that's so compelling, that particular example of one leak having that kind of impact, and that leak which would have been unknown and undetected without a satellite capability to, without satellite sensors to monitor it. So let's move on to another set of observations that I think is quite interesting in terms of the potential impact. And we'll ask Simon Tucker to speak about satellite view, and particularly satellite view is looking at high resolution thermal, is providing high resolution thermal imagery to address this context. Buildings account for something like 40% of CO2 emissions in the UK, for example. Improving heating sources, improving insulation can help reduce those emissions. But the question is, where do you target? What are the priorities? So Simon, can you talk a little bit about what satellite view is doing to measure energy consumption and how that is used? And Simon, you may be, I think, having some video issues, but we're happy just to hear you share your thoughts.
Thank you, Carissa, for that introduction. Hopefully you can hear me okay. Yep, all good. Okay, great stuff. So Satellite View is launching a constellation of thermal satellites with a fairly unique, very high resolution thermal sensor that can monitor the heat emissions from any structure on the planet. And this then has some immediate, fairly obvious sort of applications if we're on the net zero challenge, and that is buildings, yeah, especially in the UK, where we've got very old housing stock and building stock generally, are responsible for up to 40% of CO2 emissions. So if we're ever going to get to net zero, something has to be done to address this. So that is one of the main missions that Satellite View has in providing high resolution imagery. We think this can help target and those worst thermal emitting buildings first. So there's huge amounts of money being allocated towards this in the UK, Europe and the US towards retrofitting a lot of these buildings. But how are we going to allocate those funds? How are we going to actually determine they are the worst performing buildings? How are we then going to monitor longer term that those improvements are being validated and they're doing what they were supposed to in terms of improvements? And so our sensor will be able to do this. We're launching our first satellite in late 2022. And until then, we've been flying our satellite camera on a plane and starting to map out some of those cities to give early insights to people. So we've been working with Landmark around this area, who are another geospatial company in the UK, specifically around buildings and commercial buildings as a great place to start. And the UK has already got a target there that all commercial buildings have to be A or B rated by 2030. So this is something that we're working with Landmark on to potentially help some of those commercial buildings in identifying a route to get to that, because that's a very challenging task for many of those commercial organizations. So yeah, that's one of the things we're looking at. We're also very much interested in heat leakage and heat reclamation. There's huge amounts of heat losses all around the UK and globally, which could be effectively recycled with some efforts into heat networks or just into different heating solutions. This is already happening to some degree in locations, and heat networks are being talked as up as a replacement potentially for a lot of the gas central heating that's in the UK and other places. And so this heat recycling, we think it could be a very large part to play in future use cases for us. And yeah, just from early insights from our data set, we are seeing huge heat losses, which are just going straight into the atmosphere. And so if those could be recycled and redirected effectively, we think that would have a huge benefit to play.
Thank you, Simon. And I think that that's thought-provoking. I'm not sure that when people think satellites, that's the application that they think of. So the breadth of satellite capabilities and the relevance of satellite capabilities to managing climate change grows year by year. I want to close our panel, and we'll run a minute or two past the half hour. The organizers have said we have a bit of extra time. Talking about those practical mechanisms for using satellite data. Let me provide some context, and I'm drawing this content from the World Economic Forum report if there's interest. Satellites measure, we measure from space atmospheric climate data, surface wind and speed, precipitation, upper air temperature, wind speed and direction, water vapor, cloud properties, Earth radiation budget, carbon dioxide, methane, other greenhouse gases, ozone, and aerosol properties. We measure oceanic phenomena, sea surface temperature, salinity, sea level, sea state, sea ice, ocean color, and we measure terrestrial phenomena, lakes, snow cover, glaciers and ice caps, ice sheets, land cover, active absorbed photosynthetically active radiation, the leaf area index, above ground biomass, fire disturbances, soil moisture, a very broad range of data and information that would be obviously used by many different organizations in many different ways. And so how do we make that information more useful and more actionable? We'll talk about, I'd like to get all the panelists' input, but I'd like to start with Simonetta, asking you to expand a bit on the idea of an Earth Operations Center as presented in the World Economic Forum report on net zero. The idea being that it could help coordinate collective endeavors in space to address climate change. And then I'd like to hear from each of the other panelists, from Adina and Simon, on their thoughts on specific institutional or operational mechanisms for getting benefit out of the data we collect. So Simonetta, if you could start us.
Yeah, absolutely, Clarissa. Thank you very much. Well, you already mentioned a lot, but let me reiterate the fact that we do believe that the Earth Operations Center, EOEC, is really quite a good tool. It's, I would say, we can consider a decision support facility in a way. It would be a sort of a physical and functional expression also of the willingness to make that commitment. And so if a global campaign to get the net zero GHG emissions is to succeed, well, building an Earth Operations Center may be one of the most important contributions made by the global space community. So that's the approach that we have been using in trying to put together this concept. So the center will gather experts from various disciplines to use cutting edge technology and data to gain also, in a way, predictability and test solutions for Earth sustainability. As I mentioned already, would be a science, but also an engineering research center facility that could serve as a focal point for these, let's say, collection of data in a coordinated manner. And also the idea is to collect socioeconomic information relevant for ensuring long-term planetary sustainability and for the assessment of the options to achieve net zero. Clearly, the main idea is to try to facilitate collaboration between the different organizations. So this facility will help all these stakeholders to access data, shape future data collection, and also shape together and share data analysis. So in a way, this center will be added value to other efforts. And the idea is really to promote a holistic approach for decision making, and also again integrating data and expertise from both Earth system and economic, more related to economy fields. And in a way, I would say I'm thinking a little bit more on the medium term. We do hope that this will also provide global leaders with the knowledge, technologies, and community of experts needed to build a thriving future for the planet. So on one side will be a center where we collect data, also from different fields, collecting experts, so a good source of reliable science in a way. But at the same time, it can become also, let's say, the center for leaders to get the information they need for their decision-making process. So I would say that, again, it may be a very good tool if we collectively work towards its development. And then it could be one single center, one core center, plus other small center distributed in the world. This has to be discussed. The model, the final model may still be, let's say, trimmed in a way, but the concept, in my opinion, is absolutely key for us collectively to tackle this important challenge, which is climate change.
Simonetta, in your role at as the leader of the UN Office of Outer Space Affairs, you're arguably one of the world's experts on aligning a very diverse global policy community around space topics of import to the broader community. And so because of that experience, I really do find your enthusiasm for the value, the symbolic value, as well as the practical value of such an organization quite interesting. So Adina and Simon, if I could ask you if you wanted to make any final comments on, again, institutional or organizational or practical pathways that you see in the future that could help us as a community better serve the objectives of managing global climate change.
Yeah, thanks, Carissa. If I can just jump in on that one and follow up. I mean, the center is a brilliant concept for breaking down those institutional barriers and getting the policy directives that we all need to see happen. And it's great to see this initiative moving at pace. I'd add to that we also need to make sure we don't ignore the immediate, because there are immediate opportunities to have immediate impact. And that's why you'll see GHGSat often talks about today in capital letters, because we can do something about this today. And what we as a business want to make sure that we do is that we don't keep our eye just on the medium target, but we also keep our eyes on the immediate targets. So we call every operator for every leak that we find everywhere in the world. And that's a really important part of what we as a community need to be doing. So these things need to happen hand in hand. And for us, we really see an important role for the diplomatic community in this as well, because this is an international problem and it requires a different type of climate diplomacy than has actually ever been exercised before. So these are some of the things we really think are necessary, in addition to breaking down those institutional barriers and making sure that we get that policy framework right. We're just in a situation where it has to happen in parallel, and so we just need to make sure that not one of those things happens at the expense of another. So for me to be saying, we've got it cracked, don't worry about this big observation center, it's not there. No, we absolutely need the big observation center, but we also need the kind of the plucky immediate interventions that are happening in parallel. So that's my kind of core take-home message from the day.
The idea of micro engagement to achieve macro results is very compelling. And there's been I've attended a number of events trying to bring together remote sensing operators and NGOs in a broader context, not simply focused on climate. And one of the takeaways was there was interest in the data, but a real disconnect in the ability to get it and use it effectively. And so that kind of reaching out and saying, hey, we have information you need and you need to act on, it is very interesting. Simon, would you like to wrap us up with about 1 minute of content on this extraordinary large topic?
Yeah, so on the new centre, yeah, I think it's a great idea. I think having an independent centre of excellence with a diverse and complete data sets that are available for informing the leaders and the politicians, I think it can only be a good thing. So.
Thank you so much, Simonetta, Adina, and Simon for participating in this panel today. Thank you so much for everyone watching today and on future recordings. We hope that this has been useful to you, and we look forward to the opportunity to continue to engage. Please do use the platform for one-on-one networking, and I will turn the floor back over to Penelope.
Thank you very much, Carissa. Another fascinating session. Thank you to all of our contributors today for showing, for outlining, I think so clearly, how space is key in so many ways to both helping prevent climate change and to aiding the recovery of our planet. Thank you to KTN for hosting the event, and as many of our speakers have said, the platform has a networking capacity, so feel free to contact people and continue the conversation with them through that facility. Thank you all very much again, and good afternoon.